Okay, so we are still on page 20 for lesson 7. We're going to do problem B right here. Trying to graph this quadratic equation and fill in all these key features for it. So let me start by graphing this guy. I got negative 2x squared minus 5x plus 7. Get my graph. I got a pretty good zoom right there. I'm cutting off just a little bit of my maximum, so I'm going to have to go, again, I could zoom out if I wanted to. Here's another way to do it. Hit your window. I know I need to increase my Y maximum by a little bit. So instead of 10, I'm going to change that to 15. Hit graph. So I just adjusted the window right there and adjusted the Y maximum for it. So now I can go ahead and I can sketch my graph right here. I got a parabola facing down, and now I'm going to calculate my key features of this graph. So first of all, the shape, is it facing up or is it facing down? It's facing down. All right, the reason for that is because I have a negative A term. I have a negative coefficient on my first term, right? So it's asking me to calculate the vertex. In this case, the vertex is a maximum because it's the highest point, right? So I go to second calc to calculate it. I'm going to go to number 4, maximum. I need to be left bound to the maximum. That's right there. I need to be right bound. It's right there. Hit enter. And my maximum is at x equals negative 1.249999999. What's that really close to? 0. Well, no, not quite. It's really close to negative 1.25, isn't it? So we're just going to round that to negative 1.25. Sometimes your calculator gets a little bit glitchy like that. And your Y value here is 10.125. So that is the coordinates of my vertex. Those are the coordinates of my vertex. With me? Cool. The axis of symmetry. Remember that the axis of symmetry is always just x equals, and then whatever your x value is. In this case, it's negative 1.25. That line will always be your axis of symmetry. All right, I would write these up here on the board, the whiteboard, smartboard, but it messes up my calculator every time I do that, so I can't. I'm going to hold off and write those later on. Looks like my calculator got messed up anyway. So I might as well write those in. So down. And my vertex was a maxima at negative 1.25 and 10.125. All right, and my axis of symmetry was at x equals negative 1.25. So go ahead and label those points up here. I got net my vertex. And here is my axis of symmetry, and the equation of that line is x equals negative 1.25. So now to find my x-intercepts, we bring up a new calculator. Okay, to calculate our x-intercepts, we go to second calc, right? What am I looking for? What's my option for the x-intercepts? Anybody remember? I'm going to calculate the zeros, right? It's the place where my y value, places where my y value are equal to 0. So we call those zeros. Same thing as an x-intercept. So let's go ahead and do the left one first. I need to be left bound. That looks good. I need to be right bound. That looks good. My first 0 is at x equals negative 3.5. Okay. My second.
Wait.
What?
You went 0 for both of them?
Do I write the
Can
0?
you calculate 0 for both of them?
Yes.
Then how do you get both of them?
So you're thinking of how you calculate the y-intercept, I believe.
No.
All right. What's your question?
How do you get both zeros? All I get is one side.
Oh yeah, you have to do them separately. So that's what I was about to do. Is go ahead and do the second one right now. So I go to second calc again and go to 0. Once again, I just repeat the whole process. Okay. Left bound, right bound, and my second 0 is at x equals positive 1. Does that make sense, man? Just got to repeat the process and do it separately. Cool. So I got my zeros on there, and before I write those up on the board, because it's going to mess up my calculator here, let me go ahead and calculate the y-intercept. Sam, which function did I use to calculate the y-intercept? Second calc.
One value.
Good. One value. And what should I put in for my x value at the y-intercept?
It won't show.
What should I put in for my x?
0, 0.
Good. I put in a 0 for my x value, and tells me that my y-intercept is going to be a 7. Cool. All right, so now I can go over to this, and I can write in this information up here. My x-intercepts were at x equals negative 3.5 and a positive 1. Remember, that represents 2 x-intercepts right there. My y-intercept is at this point, 0, 7. So let me go ahead and put those on the graph up here. My x-intercept, negative 3.5 comma 0, 1 comma 0, and my y-intercept right up here at 0 comma 7. All right, now our favorite question is the interval question. So the interval over which this graph is increasing. Remember, I'm talking about the interval of x values here. This graph is increasing, meaning that the y values are increasing as my x starts here at negative infinity and goes all the way up to this line right here. So the way I represent that interval is I say my lowest value is x value is a negative infinity. My highest x value is a negative 1.25. I'm going to use parentheses with both of those because I don't want to include either of those values in that interval. Okay. What is the interval over which my graph is decreasing? Well, that's going to start right here, and it's going to continue on until my x hits a positive infinity over there. So the way I write that is my lowest x value is a negative 1.25. My highest x value is a positive infinity. And I use the parentheses because it's non-inclusive. All right, so those are all the key features for this quadratic equation.